All right, I want to start with this application that we did in the last class and explain something. I explained in the last class that, when you get this, in this problem, we are increasing salary by 6% if the person qualifies for it. 1 second, I have people coming in. Okay, so we want to increase the salary if the current salary is less than 20,000. Otherwise, the salary will not be increased. So we are asking for the salary from the user and reading it in the variable salary. And if salary is less than 20,000, then salary will be incremented by 6%. And the new salary goes into the same name salary. And then see out the new salary. Now this, the reason why this is going to work properly is because original salary that we got from the user is checked against 20,000. Only if it is under 20,000, then it will be changed. The same variable salary is being changed. But if this is not true, the salary will not be changed. Regardless of what happens, we are writing a salary on the screen. So this salary will be same as original salary if this person didn't qualify for the increase. Otherwise, it will be increased salary. So either way, we are writing something. And a very common error, even though I was grading the assignment that was due today, and I noticed some of you were writing this, like creating a new variable like end salary to store the salary, and then see out new salary is end salary. Well, it appears to be right, but there is logical error here, which is only if this condition is true, end salary was created. Otherwise, there's no end salary. So if this condition was not true, then this cout statement cannot work. This cout statement is outside the if, and if the rule was not met, then no new salary was calculated. So there's no value in the variable new salary. So the compiler will produce this as an error message, no value in this variable. What if I put this inside the if by putting brackets? If I put bracket like that, then both of these statements are inside the if now. So I create the new salary. If this condition is true, then I calculate new salary and write it. Okay, so now it appears to be correct, but only problem is if the salary is if the salary is less than 20,000, a new salary is calculated and the new salary is written. If the salary is not less than 20,000, nothing is written. And that's not good. There must be something on the screen. Users get confused if nothing shows up on the screen. They run the program and nothing comes up on the screen, they're confused. So even if you put another cout statement here, which is what some of you did, like this, cout, salary, just cout salary. So that way you're thinking that if the condition was not true, if this condition is not true, then no new salary is calculated. So you want to put the old salary on the screen. If you do that, then if the condition is true, then it will write the new salary and then also write the old salary. You don't want that. So it would be confusing to the reader, to the user. The two numbers are showing up on the screen. So none of these different versions are correct. The best version is to use the same variable salary to store the new salary, and then cout new salary outside the if, and no other statement. This is the best way. So if you store the new salary in the same variable salary, and then cout new salary is just salary, then it'll write the salary either way, whether it was increased or not. So this works best, and no complications if you write it this way. All right, so I just wanted to remind you on that. Now we learned about logical values. A logical value means true or false, and we can store logical value in a logical variable. A logical variable would be declared as bool, and then you can assign a condition to the bool type variable. The condition will be evaluated, and the value of that condition will be stored in W. So we did that, and we did examples, and we did all those. So we are through with all that. So now this is where we left off, the warm-up exercise. We didn't have the time for it. So I want you to write this solution for this exercise, and write it. So when you have the solution, I want you to write it in the chat. The chat works best. Or if you have it on a paper, you can show it to me um, on the screen by putting it against the camera. I'll keep the chat closed so that no one will see your solution if you write it on the chat, but you can go ahead and write your solution on the chat if you're good at typing. If you're not good in typing, then you can handwrite it and show it to me on the camera. The price of the Discate boxes, each box sells for $5.50, and that's given to you. So you don't need to ask the user for the price. Price is already given to you. So you only need to get the order from the user. The user has to tell you how many boxes were ordered. So you need to get that order and then calculate the bill. Uh, Anybody has a solution? It can be wrong, but no matter what you have, I can take a look. You have to try. If I do all these programming, you're not going to learn. You have to participate, otherwise you cannot learn. All right, I see one chat. Let me take a look. Alexandra. Okay, Alexandra has a solution. Let me see. Boxes. Uh, no, Alexander, you are getting the box, and then you're saying if box number is greater than 50, then total. You're talking about total. Total has no value. Total equal to box minus 10. The variable box is holding the number of boxes ordered. You're discounting the number of boxes. That's not right. Mathematically wrong. You need to discount the bill. So you need to calculate the bill first. You don't have the bill calculated anywhere. Okay, so before the if statement, you need to calculate the bill. That's why that's wrong.
Professor.
Okay, yes, I'm looking at Xavier's solution. Okay, move it up a little bit. Up, okay. Equal to 50 times valve, okay. See out valve. Okay, you just calculated the bill and you are printing it, but the problem says if the order is for more than 50 boxes, you're supposed to discount it by 10%. You didn't discount it.
Oh, okay.
All right. You have to calculate the bill first, and then you have to discount it if the person qualifies for the discount.
Professor, how's it now?
Okay.
Professor, I just sent mine too.
On the chat.
Yeah.
Okay. All right. Let me look at the chat. Okay. Yeah, Alexandra has another solution. Let me take a look at that first. Sine 5.5. And then right. Now this new solution from Alexandra is correct. Very good. Let me look at Christopher's. That's equal to 50. Okay, Christopher, the math is wrong because you didn't calculate the bill. You had to calculate the bill and then discount it. Oh, you're doing that. You're putting it all in this one variable, multiplied by 550 and then 10% off. Okay. But if you do that, then if the boxes are not less than or equal to 50, then you don't have a bill. So you have to write a bill regardless of whether discount applied or not. Okay. So this calculation you're doing inside the bar if statement is not going to be right because you need to calculate the bill regardless of whether discount applies or not. So you're only calculating when discount applies, which is not right. So that's mathematically incorrect. Okay, so let me copy Alexandra's solution. My pencil is not working today, so I'm going to have to handle things differently. I just copied the solution. I'm going to explain that on the board. So let me open the, all right, so pasting that solution here. I'm using Notepad because my pencil is not working. So let me use this to explain. This is Alexander's solution, which is correct. So you declare the variables and you ask for the number of diskettes ordered, and we read that into box. And then, so box is an integer variable to hold the number of boxes ordered. And the first thing you had to do is the calculation of the bill, because regardless of whether discount applies or not, you need to calculate the bill. So therefore, you should do that first, calculate the bill. And then if the order is for over 50, then apply a discount to the value. And Alexandra is using total. I would advise against that. I would use the same variable val here, right here. So this total should have been val, because look at the way you have written it. The problem is exactly what I was explaining, that you're not calculating bill, you're not calculating total if the discount doesn't apply. So if box greater than 50 is not true, no total is calculated, okay? So when you say down here, this statement will fail because let's say box is less than 50, then there was no total. And you're saying to the current value of total, add 6% of total. That's what you're saying. But there is no current value for total if the box was not less than 50. So that's an error. That's now logically wrong. There is no, the error is if box was not greater than 50, no total was calculated. So this statement cannot be executed and this statement cannot be executed. So that's the problem. So how do we correct that? Change the total to val. Use the same variable to store the new value, the discounted value. Now, this will be val equal to val plus val times 0.06. So this way, whether the box greater than 50 is true or not, val has a value. The original bill is still there. Only the discount will not be applied if box greater than 50 is not true. Regardless of what that condition was, whether that condition was true or not, val has a value in this case. So therefore, you add 6% for the tax for the original bill. If the discount doesn't apply, you still have the original bill. You're calculating and adding tax to it and writing it. If discount applied, then it was discounted. Then you're using the discounted number here if discount applied. So in either case, whether discount applied or not, your program has to work. So that's why you need to make sure the variable val is holding the answer in either case. Okay, so that was the only mistake Alexandra made, but otherwise the program is correct. So
I have a question.
Yeah, question, go ahead.
So is a sales tax added if there's no discount?
Yes. If there was discount or not, sales tax has to be added,
Okay.
right?
Oh, so okay. So if there's less than 50 boxes, the program won't do the if statement, right? It'll
Right.
just go straight to val equals val plus val times 0.06, right?
Yes.
Okay.
So if the box is not over 50, if it is not over 50, this statement will not be executed. So there will be no
Okay. So
discount.
just go to the next line.
It'll,
All right.
yes,
Okay.
there'll be no discount. It'll simply add tax to the
All right.
original bill.
Okay. That's what I was getting confused with. How do I add the sales tax?
Okay.
Yeah.
So you write this statement of adding tax outside the if, which is what is written. The way it's written here is right. It's outside the if. So therefore, if the discount was not applied, still you have a bill in the variable val and you're adding tax to it. Okay. And then you write the final bill right here. Val has the bill. So now this is correct. And if you use a different variable for this, that makes it wrong. It makes it complicated. Actually, it's wrong, and you can make it work by adding more statements, but why make it complicated? Just using the same variable is the best way. Any other question? All right, so that finishes our section 3.1, and there will be some problems from 3.1 that will be added to today's homework, but there will be also 3.2. So let's go to 3.2. And go to the beginning. All right, so that's if-else statement. So sometimes we need to say to the system, if some condition is true, then do this, otherwise do something else. So you want the system to choose between two different statements or two different set of statements when depending on a condition. So that's when you write if-else. You're going to say, if something is true, do this, otherwise do this. So the word otherwise is replaced with the else. And so here is how, here's a situation where we can use something like that. We wrote a program, simple program, writing pass if the grade is over 60. What if I want to write pass or fail? Not just pass, if the student fails, I want to write fail. So I can say if grade is over 60, see out pass, else see out fail. That's how you write if else. So here's the structure of if else statement. You need to say if and then condition in parentheses. And if that's true, then this statement will be executed. Else, that means if the condition is not true, the statement will be executed. So it'll do one or the other and then move on. Only one or the other statement will be executed. Notice the way I have written it. I moved the statement one inside by a few spaces. And then I'm writing else, lining up with the if, and then statement inside else is moved in. That's how you're supposed to write it. These indentations are for human readers. Compiler doesn't care how you write it. It will understand that the if statement ends, the entire if statement ends right here at the semicolon. Entire else statement ends with the semicolon here. The else statement by itself cannot be written. It can only go with an if statement. So if there's an else statement that cannot be paired with an if statement, then system will complain. And that's a very common error. So I need to explain that when we get to the examples. Now, if you need to do a few things, more than one thing, when the condition is true, then you have to put it in a block. A block means starting with curly bracket, you write a whole bunch of statements and close with the curly bracket. That's called a block. You can have a block as part of the if, and then another block as part of the else. You can have that. Or if you have only one statement in else, you can do that you can write without the brackets, and you can have brackets for the if. So the brackets are necessary if you have more than one statement. If you have only one statement, then you don't need the brackets. Okay, so I suppose that I write a block if else statement. That's what I wanted to write, but I missed this bracket. I missed this bracket and this bracket. Now what happens? Is it gonna say you're missing the brackets? No, it doesn't recognize that. It will recognize this if statement as one that ends right here, because if there's no bracket, there's only one statement inside the if. So this statement one is the only one that it'll execute as part of the if. That means if a condition is true, it'll do the statement one. If the condition is not true, it'll not do the statement one. But regardless, it'll do statement two, and everything below that. It'll do all these. And then when it comes to this else, it has a problem. There is no if to combine with this else, because this if statement up here ended here without an an else statement. There was no else statement paired with this. That was supposed to be an if statement without else. So this else is not paired with any if. That's so when the compiler compiles this, it'll tell you, it'll give you error message right here, the else. It'll say this else is not paired with any if. That's your error. Why? Because you missed the bracket. So only one statement was in the if, and these statements were after the if. So after those statements, if you write another else, then that's wrong. It has to be, this else has to go with an if, and there's no if statement to go with that. So that will be the error. If you miss the bracket, that's the error message you're going to get, that the else is not paired with if. Okay, so that kind of error is common, and I already saw in one of the students' assignment, the assignment that was due today. Some of you wrote with the else, and you wrote it incorrectly, and so I advise you not to use things that we haven't discussed. We didn't discuss else statement in the last class, so you shouldn't have used else statement. Because for the same reason that you can make a mistake when you don't really have a full understanding. So in the future, do not use anything we haven't learned. That's a standard rule. You should not use anything we haven't discussed in class. All right, moving on to an example. Now, first of all, let's understand exactly how this works. It'll when this if statement is executed, it will evaluate the condition first. And if the condition is true, it'll do everything here. Otherwise, it'll do everything in the else part and move on. Only one or the other will be executed, and then it'll move on to the next line. Okay, so let's see some examples. So here's that grade example. If grade is over 60, see out pass, else see out fail. Notice the way I have lined them up. The if and the else are lined up. That's because, it'll be easier for a reader to see exactly what will be done when the if condition is true and what will be done when the condition is not true if you write it this way. The if and else are lined up, and the see out pass is indented and see out fail is indented. That indentation, moving by these few spaces, is required. Otherwise, in the homework, you'll be losing a small amount of points, but you'll be losing points if you don't follow these indentation rules. Because you, as beginning programmers, you have to practice the right way of writing them, and I have to enforce that. So here is the second example. This is a problem. It says if the variable num has 10 in it, then decrease by 5, otherwise increase by 5. Okay, so if num is equal to 10, if you remember, if you write 1 equal sign, that's wrong. That's not comparing. That's saying store 10 in num. This is assignment. And unfortunately, system will not call this error. The compiler will understand this as a different request. I'll explain later why this will work, even though this is not what you meant to write. Compiler will not recognize this as a problem because it is valid. You're doing an assignment, and then after the assignment, you're saying, do this if that assignment sort of true, and I'll explain that later. But it's going to be completely wrong, completely, unintentional, not exactly what you intended to do. You wanted to say, check to see if num is equal to 10 or not. If it is true, if it is equal to 10, then you do this, decrease by 5. Otherwise, you want to increase by 5. The correct way to write it is with 2 equal sign. Only then you're comparing num and 10. And this is now a question. Is num equal to 10 or not? If it is equal, then do this. Otherwise, do this. That's what that means. Okay, so let's do another example, another simple example. We want to write a program that'll get an integer from the user, and it'll print the reciprocal of it. The reciprocal is just 1 over that number. So if the user enters 5, 1 over 5 is the reciprocal. But there is no reciprocal for 0. 1 over 0 is undefined. So therefore, we don't want to divide by 0. So if, that's why we need an if statement to see whether the number is 0 or not. If it is not 0, we'll produce the reciprocal. Otherwise, we'll have to give him a message. So here's the program. Variable int k, ask for the number and read it into the variable k. Now k is integer. And if k is not 0, then we can find reciprocal. So not equal is the way to compare again 0 and make sure it's not equal to 0. So if k is not equal to 0, see out reciprocal is 1 over float k. See, I had to do float k because k is integer. So 1 divided by k will be 0. So I could have made 1 point instead. So 1 point or float k. One of them has to be float so that the answer will come out right. Else, we put a message. There is no reciprocal for 0. So if k is not 0, we put the reciprocal on the screen. Otherwise, we put a message saying there's no reciprocal. So regardless of whether there is an answer or not, you have to give the user some message. The user needs to know what happened. The program that produces nothing in certain cases will be wrong. It has to produce something. It is a common error, to leave out this and write the program this way. If k is not 0, then write this, and you're not doing anything otherwise, which is wrong. All right, moving on to next example. Now this company wants to give a raise of 6% for those who are earning less than 20,000 now, and 4% raise for the others. Now we did a similar one earlier. In that problem, we only gave the increment of 6% and no increment if the person didn't qualify. But now the increment will be 4% if the person doesn't qualify for 6%. So if that's the case, then how do you do it? Oops, go back. All right. So salary is the variable for storing salary. Ask for this current salary and read it in the variable salary. Then if salary is less than 20,000, then increment by 6%. Add 6% of salary to salary. Otherwise, increment by 4%. So now salary has been adjusted, and notice that I'm using the same variable salary to store the new salary. That's important. If you use a new variable, you will bring in complications. So put it in the same variable, and after that, just see out new salary is salary. So regardless of whether the person got 6% or 4%, the new salary is written on the screen. All right, so let's do some exercises now. The first one is very simple elementary exercise, and I expect you, all of you, to write that. This can be written with 2 if statements, but I want you to write it with if-else statement. This can be done with if-else statement, and that's the way I want you to write it. You can either write it in the chat, or if you have it on the paper, put it against the camera. All right, I'm checking the chat. There are two in the chat. Okay, Alexandra has it right. Very good. I only have one solution so far. Okay, Jean Messias has the answer right. Two students have them right. Those students who got them right, go on to the next. Go on and do the next. If you're writing on the paper, that's fine. You can show it to me on the screen. Show it to me by putting it against the camera. Okay, there's one new message. So let me check that. Okay, Christine has a solution, but Christine, you're using a different approach. You're using the technique we learned in the last class. There's nothing wrong with that, but if you use that technique, you don't need an else statement. So this version is incorrect because of the else statement. It's not necessary. The else statement is not necessary. And you're not writing anything on the screen. So you need to use COUT statement to write your conclusion. So since we want to use if-else statement, this is not what we need today. This method is not what we want to use today, even though that method is correct. Let me copy that and I'm going to explain using that. Gene has a solution for the second question, which is good. He has it right. But let me go ahead and explain the first. Keep going and write your answer for the second problem if you already did the first problem. So I'm explaining the first problem right now. I'm pasting one student's solution here and enlarge it so that you can see. My pencil is not working today, so I'm using a different approach today. I'll figure out what's wrong with it later. But so here is what one student wrote. I think it was Christine. Anyway, okay, she got num1 and num2 from the user, and then she's using the method we learned in the last class. Max equal to num1, that should have been semicolon behind it. And then if num1 greater than num2, I think you meant to say num2 greater than num1 because you took num1 as the largest. If so after that, you should check num2 to see if it is bigger than max. That should be compared to max. Don't ever compare to the other variable, compare it to the max. And if num2 is bigger than max, then you copy num2 into max, then there will be no else statement needed. After this, max has the maximum. Originally, max was num1, and if num2 is bigger than max, copy the num2 into max. Now max has the maximum. You can see out max. See out, oops, all right, see out the max, and you'll be done. So that's, even though this is correct, this is not the way we wanted to do it today. So the better way, the way we want to do it today is, I'm going to do it down here. You want to get the num1 and num2, and then we want to use if-else statement. So we don't want to use that technique. We can just compare the num1 and num2. If num1 is bigger than num2, then we want to see out the num1. Num1 is the bigger one. So see out num1. And you're done in that case. Else, that means if that is not true, this thing is changing my writing. Else, see out num2. Okay, let me enlarge that. Okay, so if num1 is bigger, then you write num1. If that's not true, then num2 must be the bigger one. You write num2. So this is how you write it using if-else. Even though what you wrote is not, what you wrote was correct using the other technique, today we wanted to write it, use the if-else statement. So that's why this is preferred today. Anyway, so what if they are equal? You know, this when this was discussed in the previous class, one student wrote a separate statement handling equality. If num1 equal to num2, then write num1. Well, that's not necessary. You don't need, because if num1 is greater than num2, it'll write num1 on the screen. The else means if num1 is not greater than num2. If num1 is not greater than num2 means it is either smaller or equal. But in both cases, we are writing num2. Now that is correct, because if they're equal, then we can write either one as the larger one, right? So that's what we're doing. If num1 is bigger, we are writing num1. Otherwise, num2 has to be bigger or equal. Either case, we write num2. And so this takes care of all possibilities. Any question about that? Okay, and let's go to the chat and see if there was one student with the correct answer for warm-up exercise 2. I think it was Jean. And there are some others. So let me see. Tyreek Phillips has a solution for the first question. Okay, yes, that is correct. Very good. And Christine, oh yeah, that's the one I used. Okay, this is Alexandra Cotron for the second question, second warm-up exercise. She has the solution right. Very good. This is solution for the first question from Marco. Okay, Marco, this is correct, but only thing is you have these brackets. When you have only one statement in the if statement, don't write the brackets. It's confusing to a reader. And so only if there are more than one statement, you use brackets. Otherwise, just write without brackets. So the brackets should be eliminated. That's the only thing. Otherwise, this is correct. So here is Alexandra's solution for problem number 2. Let me copy that and paste it here. Okay, so what she's doing is she's getting the value of X, getting the number in X from the user. And then if X modulus 3 equal to 0, that is correct condition. To see whether X is multiple of 3 or not, you just need to see if it is divisible by 3. If it is a multiple of 3, it will be divisible by 3. In that case, X modulus 3 will be equal to 0. So dividing X modulus 3 will produce remainder of dividing by 3. So if the number is divisible by 3, then the remainder will be 0. So if X modulus 3 is 0, then it is a multiple of 3. Otherwise, it's not multiple of 3. That is correct conclusion. Any questions? All right. Moving on, that finishes to 3.2. So there will be questions from 3.2 in your homework. I will put the correct number, the problem numbers that you need to do on the link itself. So when you click at the link, you will see the problems you have to do. All right, the nested if statement is next. Sometimes we have to put many if statements, one if statement, and then another one inside that, and another one inside that. Well, that's commonly needed in computer programming. So we need to understand how to nest them, how to put many one inside the other. Now, sometimes you can handle the situation by writing several conditions in one if statement. Now, writing several conditions in one if statement is something we're going to be doing in the next section. So let's not bring that up here right now. In some situations, you cannot just combine conditions. We really have to write many if statements. So that's the situation we're going to analyze today. So if you need to write many if statements, then they can go one inside the other. And there are all kinds of different ways of writing them. So depending on what you need, depending on the situation you have to, you may have to write a version of nested if statement that we are not discussing here. So it is all, entirely up to the situation. So we are discussing two examples, basically, two examples that are common. One is if condition A is true, then you need to write another if. As you can see, I'm indenting that second if because only this if is inside the previous if. If that's true, then we want to check another condition. So I'm writing another if. If that is also true, then statement 1 is executed. So can someone tell me statement 1 will be executed under what circumstances? What conditions have to be true?
A, B, and C.
A, B, and C, all three have to be true. Now, when would this statement 2 will be executed?
If any one of them is wrong.
Any one of them true? No.
If
If all of them are...
Or if all of them are true, statement 1 will be executed.
If statement C is wrong?
If statement C is false, but statement A and B are true, that's the only situation when statement 2 will be executed. Because only if condition A is true, it'll go to this if statement. If condition A is not true, it won't even go here. So if this is true, then this if statement will be executed. If condition C is false, it'll execute statement 2. So that's how it goes. And as you can see, I color coded them. Otherwise, it would be difficult to see. This if is paired with this else. And the next else is paired with the previous if. The next else is paired with the previous if. That's how the system will handle them. So here's the rule. Every else will be paired with the closest if statement that is not already paired with another if statement, another else statement, that is. So every else is paired with the closest if that is not already paired. So this else is paired with this if because that's the closest one. This else is not paired with this because this if is already paired with an else. So this else statement is paired with this if. And this else is paired with this if. I color coded them. so you can see better. If the condition A is false, which statement will be executed?
Four, would it be four?
Condition A is false. Which statement will be executed?
Statement 4.
Statement 4. Right. If condition A is true but B is false, then
3.
3. Right, 3. That's how it goes. So as you can see, you won't be able to color code them when you're writing it in, when you're actually typing your program. Your program editor doesn't handle colors. So you are going to have to do the indentation. The indentation is the next thing that makes it easier to see what is paired with what. The if and this else are lined up, if you can see. And everything inside that if is moved in. And then this if is lined up with this else to show that they are the one paired. And this if is lined up with this else to show that they are paired. And you're supposed to follow that rule when you're writing your program. Your next programming project is going to involve nested if statements. And so you need to follow these rules of indentation to make it easier to read. Okay, so here's another version. If condition A is true, then you want to carry out a certain statement and then check another condition, which is common. So in this place of statement, you can have several statements. So you're going to do a bunch of things, and then you want to have another if statement checking another condition. If that is true, then you want to do a bunch of things, then check another condition. So these are all commonly valid forms of nested if statements. So depending on your need, you have to adjust your nested if. But what I'm going to explain next is an example of application of nested if. And after that, we will learn a better way of writing nested if that works in most cases. So this kind of nested if you have to write it this way, then you can write it, but there are ways not to write this way. I'm going to explain that in a few minutes. So let's use this if statement for the next example. Next example is about grade. But before that, let me re-emphasize exactly how else statement and if statements are handled. Every else statement is paired with the closest if that is not paired with another if. And that means that you cannot have anything else. So say, for example, let me go back here. Suppose that you have this if, and then you have a statement right next to it, right underneath that. Let's say you have a statement here. Okay, you have a statement there, and then you have this if. So now there's a problem. If you don't use brackets, you have a problem because this if is paired with this statement 0. And so the statement 0 is the only one that is inside this if. Remember, if there's a statement, no bracket, then that only one statement will be part of this if statement. So now this if is separate. So this if has a nested block. That means this part is right. This if is paired with this else. The red if is paired with red else. Orange if is paired with orange else. All that is right. But where exactly is the problem? What error message are you going to get? This is wrong. You're going to get error message. Anybody see what the error is or what error message you're going to get?
It's just gonna do the green one. So it'll disregard everything that's below statement 0.
And you're saying it'll work without any error?
No, it'll just do statement 0 or statement 4.
No, that's the point I'm trying to make. It will not. So okay, his answer was, if condition A is true, it'll do statement 0, else it'll do statement 4. Well, it would have worked that way if none of these are there. But since all those are there, this if, and also since this statement 0 is there, this if and this statement finishes that if. There is no else to be paired with that. This else is not going to be paired with that anymore. All right, that's the point I'm trying to make. Because you have this statement that completed that if statement. This condition, this statement 0 completed this if statement, and there is no else paired with that. If you wanted an else statement to be paired with that, that else statement should have gone here, right next to it, right there. And there are other things. So because of other things, the green else is not going to be paired with the if. Okay. So the error message you're going to get is this else is not paired with any if. That's the error message you're going to get because of these other statements. So you have to be careful not to do that. If you want this statement to be part of it, then here is what you have to do. You wanted to have that statement as part of that block, then you need curly bracket beginning here and ending here. And those curly brackets should line up right there. So now the else is paired with that if, because if condition A is true, all of these will be executed, and condition A is false, then the else part will be executed. Okay, so now it is right. So it's a common error to miss these brackets and messing up the whole thing. I just wanted to show you that example, but other than that, you understand exactly how they're going to be paired. So let's do our next example, which is earlier we wrote a program which will write a pass or fail grade. But what if you want to write letter grade, A, B, C, D, F? We can write the program to write a letter grade, and here is one version of it. The problem says there are 3 test grades, and you need to get 3 test grades and find the average. And then if the average grade is over 60, then student passes. And if it is over 70, he will get a C. If it is over 80, he or she will get a B, and so on. So the usual points, usual grades, 60 is pass, 70 is C, 80 is B, and so on. All right, so if you want to implement that in your program, then you can write this way. This is one version. This is not the best version, but this is one version. I wanted you to see that it can be written with the nested if that we saw earlier. So if average grade is over 60, I cannot immediately write D grade, because if it is over 60, it could be over 70. It could be even over 90. So I have to go ahead and check the other conditions. So if that's over 60, then check to see if it is over 70. If it is, then check to see if it is over 80. If it is, then check to see if it is over 90. If it is over 90, then we can conclude that the grade is A. Else, so this else will be paired with this if, and that means average grade over 90 is not true, but over 80 is true. That's when this else will be executed. So in that case, we know that the grade is B. So we write that. And the next else will be paired with this if, the previous if, and that will be executed only if average grade is not over 80. But already average grade is over 70. Only when it is over 70, it'll come to this if anyway. So therefore, it is, so the situation we are looking at is average grade is over 70, but not over 80. In that case, we are writing C, which is correct. And the next else will be paired with the previous if. So that will be executed only if average grade greater than 70 is not true. If it is not greater than 70, we already know that it's over 60, so it is pass, D. So you'll write a D. Next else is paired with the very first if, and only if average grade is not over 60, that else will be executed and the grade is F. So this will be writing the correct grade. But as you can see, you have to properly indent them. Otherwise, it's hard to read and hard to figure out which else is paired with which. So proper indentations are required. And even then, it's not the easiest to read and follow. So there are better ways. And the better way is what we're going to learn next. Any situation where you need to write a nested if statement can be handled using this almost always. Very rarely you need other structure. Almost always this structure works, and that's why it is specifically named as if-else if structure. And we recommend you to use this whenever possible, and almost always this can be used. So let me explain that first. If condition A is true, you have a statement 1. Only if this statement can be replaced with a bunch of statements if necessary, but then you have to have curly brackets. After that, you don't write another if statement. Instead, you write else, always. So if condition A is true, then one statement or many statements written there will be executed. Otherwise, you have another if statement next to it. So you actually should write them next to each other so that it's easier to read. And then you need a space here between else and if. Otherwise, it'll be incorrect statement. So we are basically writing an if statement after the else, but you're writing it next to it. So else if, another condition, if that's true, statement 2 will be executed. Else if, keep writing else if, else if, else if. And then at the end, an else, no more if, no more condition to check, else do this. So notice that if condition A is true, statement 1 is the only thing it'll do. It'll only do one of these statements. If the condition A is not true, it'll go to the else part and checking this condition. If that's true, it'll do statement 2. And otherwise, it'll do statement 3. It'll check this condition C, and if it is true, it'll do statement 3, and so on. At the end, this else will be executed if condition D is false. This is false, and it'll do statement 5. So this is not really not the same as this nested if. It's a slightly different structure, but it works beautifully in most situations, and it is much easier to use and much easier to read and understand also. So therefore, you're advised to use this whenever possible. Now I'm going to write that grade program using this. This can be used in most cases. So here's the grade program, writing letter grade using this method. Get the 3 grades from the user, find the average grade, and if average grade is over 90. Now I'm starting at 90, but even if you start at 60, you can still work with the same structure and finish the program. So if average grade is over 90, then the grade is A, very clear. I don't need to check anything else. Else, that means if it is not true, then check to see if this is true. If it is, then write B. Otherwise, check another condition, compare it against 70. And if it is true, grade is C. If that condition is not true, then go to this else. So only one of these will be true, and it'll write only one grade. If average grade is over 90, it'll write the grade A, and that's it. It won't go to the else part, right? So therefore, it won't do any of the rest. Only if average grade over 90 is false, then it'll go to the else, and it'll compare this. And if that's true, it'll do this and finished. It won't go to the other part because this condition is true means it doesn't go to the else part of this if statement. So only one condition will be true, and it will write only one grade, and that's the end of it. And as you can see, it is much easier to write and much easier to read and follow. So it is advised that you use this structure whenever possible. And almost always we can work with this to do our problem. So I'm going to do an example now of application, and I'm going to try to use this structure. So it can be used, like I said, in almost all the situations, this structure works. All right, so here's my example. Sorry about that. I thought this pictures will be interesting, but they are distracting. So anyway, so here's the application. The tax table. Here's the tax table. If the income is below 20,000, then the tax will be 5%. Income is between 20,000 and 30,000, the tax will be 6%. These are tax brackets. You understand that. So, I mean, the actual tax law is a very large number of rules, but I simplified it to a smaller bracket, smaller situation. 30,000 to 40,000 in that bracket, 8% tax. 40,000 to 50,000, 10%, and so on. Now, these brackets are written this way. It doesn't mean you have to combine conditions. You don't have to. You only have to compare the income against one number. And I'll show you in a minute. And then it says, there's an additional thing here. It says when the tax computed using the above rule is over 15,000, then the tax will be discounted by 2%. So that's another thing you need to take care of at the end of the program. So write a program that obtains the annual income from the user and prints the amount of tax on the screen. So first we have to incorporate this tax bracket rule to find the tax. And then if the tax is over 15,000, we have to discount it by 2% and then write the tax. So that's what you need to do. The first thing you need to do is get the income from the user. So this is a tax program that'll figure out the tax for this user. But so you have to begin by asking for the income and then compare income against 20,000. So it says below 20,000, then the tax is 5%. You can start right there by saying income less than 20,000. If income less than 20,000, 5% of income is the tax. Else if, see now it's already, if it is below 20,000, it'll be 5%. The else part will be executed only if it is not below 20,000. So this part you don't need to check. It's already, only if that is true, it'll go there. So you only need to compare against the 30,000 in the next line. So here's how the program goes. Float, income, tax, two variables. Ask for the income, read it in income. If income is less than 20,000, tax is 5% of income. As simple as that. And everything is finished right there. If that's true, it won't do any of the rest of the block. Only if income is not less than 20,000, it'll come to this else. This else is executed only when income is over 20,000. So here's a very common error. You know, it's not error, but it's not advisable that you do that. Income greater than 20,000. We'll be learning how to combine two conditions. You can combine two conditions with the two and symbols. And so this is a common way students will write, and some of you are going to write it. No matter how much I say, students always write this. Else if, so because the problem says if the income is between 20,000 and 30,000, then the tax is 6%. Just because of that, the students who says if income is greater than 20,000 and less than 30,000, then tax would be 6%. Now this condition right here is unnecessary. Why? Because already this is not true, means income is greater than or equal to 20,000. That's the case we are looking at. That's when it goes to this else part. And so by making the system check this condition again, you're just making it work unnecessarily. Remember, making the system work unnecessarily makes the program run slower. It's a tiny bit slower, but still we have to care about slowing down our program. We have to make the program run as fast as it can. That is the rule in programming. So unnecessary work for the system should not be given. For that reason, this is considered to be bad practice because already we know this is true. So you're checking that again. Even though system will accept it and do it, it is not acceptable for the programmers as a rule because you're slowing down your program. So this is unnecessary, and I'm advising you not to write that. You'll be losing small amount of credit for writing that because you're making the program slower unnecessarily. So that should be eliminated because already that's true when it comes to this else. So you only need to check one condition. If this is true, then that means income is between 20,000 and 30,000. So that's when 6% will be the tax. Else, this also will be executed only when income is not less than 30,000. So it's already over 30,000. And if it is under 40,000, then it's in that bracket. So tax is 8%. Here, taxes in the bracket of 40,000 to 50,000 range, between 40,000 and 50,000. So it's 10%. Else, the last part here, 50,000 or over, then 12%. That'll be the else part here, which means if this is not true, that means it's 50,000 or more. In that case, 12% income, 12% of the income will be the tax. So that this entire block of if statements will calculate the tax. After that, we need to do the discount. So after all that is finished, you need to say if tax is over 15,000, then 2% of tax should be taken away from tax and the result should be put in tax. So that way you're discounting the tax by 2%. Only after that, you write your answer. Tax is equal to this after the discount. So that finishes the program. So remember to write your program using this method and do not write unnecessary additional conditions that will make the program slower. That'll make the program run slower. All right, any questions on this example? All right, we are out of time. So I'm going to begin with warm-up exercise in the next class. So I strongly advise you to try this before the next class. That way you will understand it better. You will understand the rest of it better. But we are almost done with this section except this warm-up exercise. So we'll be finishing, we have to finish this in the next class and then move on. Other than that, we are almost done with 3.2. So you're going to get almost done with 3.3 as well. So you're going to have homework problems on 3.1, 3.2, 3.1, just a couple of questions, and then 3.2, some questions on 3.3, not all of it. So I'll put those numbers, correct numbers on the link itself and submit them before Wednesday. All right, that's all for now. Enjoy the rest of the day, and I will see you Wednesday.
Thank you, Professor.
Thank you. Have a nice day.
Bye, Professor.
Bye-bye.